Hi class, this is Mr. Kramer coming to you live from my home. I hope you guys are all doing well. So let's get right into our first lesson. So this lesson is going to be on how to rewrite from exponential to logarithmic and from logarithmic to exponential. So a logarithm, by definition, a logarithm is an exponent. Notice here we have our log problem, and notice it's equal to an exponent. So the answer to a log problem is an exponent. That's very, very important to know. Okay, so let's first of all, if we have some base, we'll call that b, raised to an exponent, we'll call that x. It's going to be equal to some number. And so this is an exponential format. Okay, some base raised to an exponent equals a number. For example, we could have base 2 raised to the third power equals 8. Now what we're going to learn how to do here is how to rewrite this in log form. Okay, so it's just a different format for writing this equation. So let's go ahead and write the general idea here. So log, L-O-G, stands for logarithm. That's what L-O-G stands for, logarithm. So log, and then our b, the base, that's this b right here, is the subscript number of some number. That's this number here, that goes here, equals, and remember, it's equal to what? Remember, this is very important. It's equal to the exponent. So in this case, it would be x. So if I gave you this and I said rewrite this in logarithmic form, we would start by writing log. Okay, then the base, that's the 2, goes down here. Okay, then the number, that's this number here. So it's kind of like going around in a circle, starting with the base, then the 8 goes on the same line as the log, equals, and then remember a log is equal to an exponent, in this case 3. And that's how you change it from exponential to logarithmic form, and vice versa. If I wanted to go from here to here, we'd start here at the base, then we go kind of around in a circle, like I said. This is the exponent, equals the number. And now we're back to exponential form. Okay? All right, some rules. So some rules for logarithms. First of all, the base, this subscript number, has to be, and this number here, these two numbers right here, have to be greater than 0. So no negative numbers. Also, the base, another rule, the base, this number down here, cannot equal 1. Just a couple rules to keep in mind. All right, let's walk through some examples, and then we'll be done, and you can start working on your practice problems. So it says rewrite the following as logarithms. Okay, so we're in exponential form, so we're going to write it as a log. So we write log, then the base, which in this case is 10. Okay, and we're going to go around in that circle. Then the number is 100. Remember, that's on the same line as the log. Don't have to put that line there. Please don't, unless you need it real light. Equals, and a logarithm is equal to the exponent. Okay, let's try another one. Convert from exponential to log. So we start by writing log, then the base. Remember, the base is the subscript number, going around in the circle, of 2 equals finishing up with the exponent. Okay, this one's a little bit different. We have e. Remember that e is the base of a natural logarithm. So for natural log, instead of writing log, we're going to write ln. ln stands for natural log. So anytime you're using base e, we can use natural log, okay? And natural log is always base e, okay? So starting here with e, we do not have to put the e here, okay? It's assumed to be there. You do not have to put the e there. Going around in the circle. Ending up with the exponent. Now, writing natural log is the same thing as log base e. This is the same thing as this. Same thing. Okay. Now, going the other way, rewrite the following as an exponential function. So here we're in log format because of the log, and we want to go to this format. So we always start at the base. So we're going to start with 2, and we're going to go around in a circle. Remember, that's the exponent, equals, and then the number goes last. And you can always test to see if it's working properly by seeing if this is a true statement. 2 to the 4th power is 16, so you did it right. Okay, next one, start with the base. Going around in a circle. Exponent, number. Ooh, do you remember the base for this one? Are you paying attention? Corey, wake up. Look up here. Yeah, base E. So now we're going to need to put the E down as the base. Okay, going around in that circle. That's the exponent. Equals 8. All right. So something to keep in mind here. A common logarithm has a base of 10. So when I say a common logarithm has a base of 10, it's going to normally look something like this. Example, log of 100. Notice what is it? It's missing. The number is missing. So if the number is missing, okay, that means the base is equal to 10, okay? And this is a common logarithm. Common logarithm. All right. Evaluate the following. So to evaluate this problem, we're going to go ahead and put an x here for our answer. And we're going to convert it to exponential. So 10, remember this is a common logarithm, 10 to the x power equals 100,000. Okay, now remember we learned how, what am I doing, Mr. Kramer? 10 to the x power is equal to 100,000. So using our power table chart, we find that 10 to the 5th power is 100,000. So remember, when your bases are the same, then we can set the exponents equal to each other. X equals 5. All right, let's take a look at this one. So again, converting it. This is a common logarithm, so 10 raised to the x power equals 1 over 100. Remember, we want to make the bases the same. So we are going to make this base 10, which would be 10 squared. Then remember, we learned that we need to move that base to the numerator. And what happens to that exponent? Good job. You remembered. I'm proud of you. The exponent becomes changes its sign, basically. So it goes from +2 to -2. See, you remember what I taught you. Good job. So now that the bases are the same, we're going to set the exponents equal to each other, and we have our answer. Don't you feel like you're getting smarter? You miss this, don't you? I know I do. Okay, so let's do the next one. Base is 10 to the x power equals 1. This one's tricky because it's a 1. So who remembers? Raise your hand, don't shout it out, please. Raise your hand. Oh, wait a minute. Never mind. 10, if you use your power table and you go to base 10 on your chart, 10 to what power is 1? That's right, 0. So if we do 10 to the x is equal to 10 to the 0, 10 to the 0 power is 1, then we have x equals 0. All right, you guys did fantastic for our first online lesson. Give yourself a pat on the back. You guys did a great job. Please, if you have any questions or need some clarification, please email me and let me know, and I'll do my best to get back to you as soon as I can. Please do the practice problems on the back. Remember that all packets are picked up on Monday morning, and then when you return the following Monday to pick up your new packet, please make sure you turn in your completed work with your name and period on the paper along, and I believe I put my name on all the papers. But if you do see a paper without my name on it, please put Mr. Kramer on the paper as well. Thanks. Have a great day.